We also have a specific rule that we need to follow whenever we're asked to find the derivative of the quotient of two functions. So for a function y equals f of x divided by g of x, so some function divided by another, dy over dx is found by taking f prime times g of x. So this starts off quite a bit like the product rule. In the first term, take the derivative of the first function. In a second term, we'll take the derivative of the second function. But then what changes is instead of adding these two results, or adding these two expressions, we'll subtract those and then also divide by g of x squared. So again, we start off in the numerator with something that looks a little bit like the product rule, but we change that to subtraction and divide by the original denominator of that function squared. Or getting rid of some of that of x notation, we can simplify this a little bit to write it as f prime g minus fg prime over g squared, just to maybe see a little bit better where we're supposed to substitute and how we're supposed to evaluate that. So keep in mind, just like we talked about with the product rule, that to take the derivative of f of x over g of x, that is absolutely not equal to just taking the derivative of the numerator divided by the derivative of the denominator. We need to make sure that we're using this rule and using this approach anytime we have the quotient of two functions. So for instance, in example 5, our function in the numerator is x, and our function in the denominator is x plus 45. So to find f prime of x, we take the derivative of x, which is that function in the numerator, times the denominator, and then subtract the numerator times the derivative of the expression in the denominator. And then we divide by whatever that original denominator is, squared. So differentiating here, x, the derivative of x will give us 1, so we get x plus 45 minus x times 1, so just minus x, over x plus 45 squared. So here the x minus x will cancel, which leaves us with just 45 over x plus 45 squared. So again, this is obviously a longer approach than just differentiating the numerator divided by differentiating the denominator, but that approach would lead us to an incorrect result. It wouldn't get us to this correct derivative that we want to reach. In example 6, we have the numerator as x squared plus 2, the denominator as 9x minus 8. So to find dg over dx, we would take the derivative of x squared plus 2 times 9x minus 8 minus x squared plus 2 times the derivative of 9x minus 8 all over that original denominator squared. So then we just look at differentiating the pieces that we have to differentiate. So x squared plus 2, that derivative will be 2x times 9x minus 8 minus x squared plus 2 times 9 all over 9x minus 8 squared. So distributing through, we'll get 18x squared minus 16x minus 9x squared minus 18. So taking the 2x and distributing it through the 9x minus 8, and taking the 9 and distributing it through the x squared plus 2, and then also distributing that negative through. So if we wanted to, we could rewrite this portion as minus 9 times x squared plus 2. So just rearranging that order to see that distribution a little bit better. Over 9x minus 8 squared. So simplifying any like terms in the numerator will give us 9x squared, negative 9x squared, minus 16x. I'm sorry, that should be a positive. So the 18x squared minus 9x squared will give us positive 9x squared minus 16x minus 18 over still 9x minus 8 squared. The expression in the numerator can't be factored, so we're not going to be able to cancel anything with the denominator, meaning this leaves us with our final result.